This conference will now be recorded.
Okay, so welcome back to the session. This is Big Data Masters program, and we are going through with Apache Hive. Okay, Hive, that is the data analytics tool. We used to say this is a data warehouse, and it is utilized to solve the analytical problems. In the previous session, what we have seen, we have gone through with acid properties, and over there, what we have seen that this Hive is not ACID compliant, although the RDBMS or databases are the ACID compliant. We have gone through with these properties in detail. Then we have seen certain stuff that is with respect to data and metadata. Okay, what is happening once we are having data uh, once we are trying to load the data inside the RDBMS, then we are going to create the schema, then load the data, and then we will be able to query data on top of that particular table. Okay, so over here inside the RDBMS, schema is on, schema is created while or created in order to cite the data. Okay, so schema on write, what I can say, schema on write, and with respect to the Hive, what we are having schema on read, schema on read. So what is the meaning of this? So if you are trying to read or trying to query the data which is stored inside the HDFS, at that moment you are going to create the schema on top of that particular data, and you will be able to have that data, or you will be able to query on top of that particular data. That is with respect to Hive. So we have gone through with this particular stuff, and we have created certain tables, and then in RDBMS, what we have seen, we have first like created the table based upon the structure which is given inside the file. We were having an Excel file which was having certain columns. Based upon the columns, we have created uh, the schema inside the MySQL, and then we have loaded the data inside that particular table which we have created, and then we were able to query on top of that particular data. Okay, inside Hive, what we have seen, uh, after creation of tables, once we were trying to insert the records, at that moment MapReduce jobs was running. Okay, so that is as per our expectation, because like MapReduce, we are trying to solve the big data problems. Okay, say we are having huge amount of data, and this particular data we are trying to process with Hive, and Hive is going to do what? It is going to convert this particular code inside the Java, and that is given to say MapReduce. Okay, and then it will be able to get processed onto the MapReduce, and that is nothing but processing engine inside the Hive, inside the Hadoop. So this is nothing but processing engine. So we were able to process the data with MapReduce, and over here, this is the beauty of Hive, that there is no need to learn Java and all. Okay, we are just writing our code into SQL-like language, that is HQL, and we are able to do the analysis on top of this particular data with the help of MapReduce processing engine of Hadoop. Okay, so uh, what I can say, Hive is nothing but a SQL wrapper. Let me write it down. Hive is nothing but a SQL wrapper on top of Hadoop, perform the analysis on huge amount of data by writing SQL-like queries. It's very simple. And with the help of this particular definition, we are able to get what exactly Hive is. So Hive is SQL wrapper on top of Hadoop, and we are trying to write down our code in SQL-like language in order to process this particular huge amount of data with this particular MapReduce processing engine of Hadoop. So that is what. Now inside Hive, friends, there are certain things. What I can say, the data types. Now, like if you are going to uh, learn a particular language, okay, or it might be Python, it might be Java, it might be Scala, it might be C, any language. If you are trying to learn a new programming language or a new programming methodology, then you must have the understanding about its data type. So inside the Hive, we are having certain data types, and we are going to discuss about those particular data types. So data types in Hive, data types, data types in Hive. So there are two types of data types inside the Hive: simple data type and complex data type. Data types. Okay, so simple, like you already know, say string, integer, okay, boolean, okay, boolean. These are nothing but the simple data type, float, float, okay. And these particular data types are used to handle single value. These we have heard about these particular data types. These data types are used to handle single value. Okay, and what I can say, these are the examples. Example: string, integer, boolean, boolean, float. Okay, so these are the simple data types. Now what about the complex? If you want to store more than one value, then what are the different data types inside the Hive that we are having? So in order to handle multiple values, what we are having complex data type. So inside the Hive, we are having three types of complex data type. Let me write it down. Three types of complex data type. First one is, say, array. Array. Okay, so array is nothing. This is the the collection of homogeneous elements. This is the collection of homogeneous elements. This is the collection of homogeneous elements or values. Okay, for an example, say array, and I can say I can provide your name, say Pankaj, okay, and say Gaurav, okay, Gaurav, say Vikas, okay, Rohita. Okay, this is nothing but array, an array. So over here, previously, like what we have seen, say integer one, that is used to handle single value only. But over here, we are having multiple elements. So this is nothing but a complex data type in Hive. And why we are learning these particular things? Why we are going through with these particular things? Because we have started Hive, and what will be our methodology in order to cover Hive? So first we will be going through with the theoretical aspect. So currently we are going with the theoretical aspect, say what is Hive, what is the difference between Hive and RDBMS and analytics and transactional. Okay, certain stuff from the Hive, say uh, like we are going to create tables, and tables are having two uh, main forms, data and metadata over here inside the Hive. So whatever we have covered and whatever we are going to cover in today's sessions and next session, that will be with respect to the theoretical part. Okay, or probably in today's session we will be having certain flavor from the practical side, and then we will be deep down in the Hive, and we will be going to learn from the practical perspective. But before, like, we are going to build a base, so you will be having the good understanding about Hive, and then you will be able to write down the HQL code, that is Hive query language, or that is nothing but the SQL like code, in order to do the analysis on top of our data. Okay. Okay, so because of that, like, we will be going to utilize these particular data types. So we are going through with these particular uh, things, like how to get the understanding about data types in Hive. So complex data type, first one is array, that we have already seen. This is nothing but the collection of homogeneous data type. Homogeneous is nothing but similar kind of data is available. So if I'm going to mention, say, Pankaj 1, okay, so this will not be an array, because over here the data type is string and this is the integer value. So it is the collection of homogeneous data type. Homogeneous, that is the similar type of elements. So that is nothing but an array. Now, the second complex data type what we are having inside the Hive, that is nothing but the map. Map. Okay. So map, uh, those who have gone through with Python programming language, or those who are having the basic understanding about the Python programming language. So inside the Python, we are having one data type, that is dictionary. And dictionary. Okay, so map is similar to dictionary, and inside the dictionary, what we are having key and value pair. Key and value pair. Okay, so map is similar to dictionary. It is similar to dictionary and Python, and we are having key and value pair. Okay, so key and value pair. Just have a look over here. Say I'm having uh, these particular, let me try to take these particular elements or values. So say Pankaj, and let me try to write it down in this particular way. Pankaj, and this is a key, and it is having the value, say let me try to mention age, say 38. So this is the age of Pankaj. Then Gaurav, let me try to mention, say 34. Okay, so say 32. Okay, and Rohit is having, say, is, say, 31. Okay, so what I have done, I'm having nothing but the key and value pair. Over here, this is the key, and with respect to this key, this is value, this is key, this is value, this is key, this is value. So if you need to get a certain value, okay, so you just need to refer the key, and we will be getting the value with respect to that particular key. We need to refer the key in order to get particular value. Okay, now, main thing what is there inside the Hive, like, these particular keys must not be repeated. These particular keys must not be repeated. It's not like, say, Pankaj will be having one more Pankaj over here, that is having, say, age 36. So it will be difficult to identify which Pankaj we are going to refer. So keys are not repeated over here inside the map. Keys must be unique. Let me mention over here. Keys must the unique in nature, in map. Okay, so that is the second complex data type what we are having inside the Hive. Now the third data type, third complex data type is nothing but struct. So once we are talking about struct, so this is nothing but like a class. This is nothing but like a class, and over here we will be having different data types altogether. Different data types altogether. Let me try to show you with an example. Okay, so let me try to mention the struct, and inside the struct I'm going to say define student as a struct, say student, and struct, and inside the student that is struct, and I will be having what? I will be having say student roll number. Okay, and say is, okay, say subjects. So I will be having different types of data type over here. So roll number, what I can say, I can mention integer. Okay, and is I can mention the integer. Subjects, what I can mention, say array of what? Array of say string. Array of string. So I can mention in this particular way as well. So over here inside the struct, I will be having the combination of multiple data types, and it is going to act as a class. So over here, like the student is a class, and it is holding multiple data types altogether. Okay, and like these are going to say represent the information with respect to this particular student. So even like if you want more fields over here, you can add more fields, and these particular fields are going to specify this particular student. Like student is this particular roll number, is subjects. Okay, so this is with respect to the struct complex data type what we are having inside the Hive. Okay, so this is the first topic, like what I want to cover, complex data type in Hive. Just have a look and ask if you are having any doubt. All of you?
So, so
Yes, yes, yes.
what is the difference between variable character and array? So you put in subject with beside with you put like array string and all. So can we add it here variable character? Like
Varchar is with respect to MySQL. Variable character, say
uh,
we have seen the data type of Hadoop. Let me try to mention. Inside Hadoop, what we are having text as a data type. Okay, but in Java, what we are having string. Okay, so inside the Java, what we are having data type integer, but inside the Hadoop, what we are having int writable. Int writable. Okay, Java. Okay. So over here, the main thing is that like the content and all that will remain same. Inside the Java, we are going to denote the string information. Say Gaurav is nothing but a string. Okay. We are going to denote it with string. But for this, what we are having text in Hadoop. Okay. And for this in MySQL, what we are having varchar. Okay. Variable character. So varchar is with respect to MySQL, and string is with respect to Java, text is with respect to Hadoop, and like based upon the programming language what I have mentioned, uh, these particular things will keep on changing based upon the language. Like the matter, the content will remain same, but the keyword will change. Okay, so keyword, this variable character that is with respect to uh, MySQL. Inside Hive, what we are going to mention, we are going to mention string only. We have mentioned string only. Let me show you. Okay, so in yesterday's session, what we have seen, once we were creating the table, just have a look over here. So once we were creating the schema, so employee name is nothing but the string type. So we have given the data type variable character, and its length will be up to 255, 255. This is the maximum length of variable character. So we have mentioned in this particular way. But once we were defining, creating this particular table inside the Hive, we have used what? We have used string. So this is nothing but denoting the data type with respect to a particular language, right?
Okay, ji. Got it.
Okay, clear? Fine so far, all of you?
Yes, Ashok.
Is it clear
Yes,
so
yes,
far?
yes, Ashok.
Perfect. Okay, so this is nothing but the complex data type inside the Hive, and we have gone through in detail. Like there are three main data types: array, maps, and struct. And we will be going to use these particular data types. We will be creating tables on by utilizing these particular data types, and then we will try to do the analysis. Okay, so we will see these particular things with practical. There is no need to worry, but at this moment just try to understand what is array, map, and struct, and like uh, uh, before like going through with the practical, you will be having enough understanding about these particular topics. So that is complex data type. Now another stuff what we are having, user defined functions. User defined functions. Okay, UDF. User defined functions. So, or sorry, built-in functions. Sorry. So, built-in functions inside the Hive. These are the three types of functions. Three types of built-in functions. Three types. Sorry, I have three types of built-in functions are available in Hive. First one is user-defined function. Second one is a user-defined analytics function. User defined analytical function. Third one is user defined table generating functions. Okay, and you might be having confusion. Over here I'm mentioning say built-in function, and over here it is like say user defined functions. Although like these are the built-in functions only, and we are going to utilize these particular functions in order to perform the the operations. In order to perform a specific task, we are going to leverage these particular functions, and these are nothing but built-in functions. But user defined function, this is as per like the the terminology which is given by Hive. Okay, although like this is creating a confusion. Okay, like because these are the built-in functions only, and we are going to utilize these functions. We are not going to define by ourselves. So these are built-in functions only, but the name is given say user defined functions. So once we are going to pick the first one, that is UDF, user defined function, UDF. And user defined functions is working on the principle, like if you are providing one row as an input, it will provide it will provide one row in output. Let me try to mention. So say what we are having, UDF over here. Just try to focus UDF. And if inside the UDF, what we are going to do, if we are going to say give one line, if we are giving one line or one row, input say single row, and the output will be single row inside the UDF. So once we are going to utilize UDF, so it is going to take single row as an input, and it will provide you the single row as an output. For an example, say we are having trim. If you are uh, going to trim certain character, so trim is one operation. Concat, concat is one operation. It is going to take one row, and it is going to provide one row as an output. Length, if you are going to calculate the length, so say length is say length of say uh, booster, booster. Okay, so booster analytics say we are going to check the length of this particular string. So the length of this particular string, what it will be, it will be say 7. So we are providing one single row as an input and providing me single row as an output. So length, trim, concat, round. Okay, these are nothing but the UDF functions, and based upon our requirement, we are going to use these particular UDF or built-in functions from the Hive side, and we will be able to fulfill our operations. We will be able to fulfill our need. That is UDF. The second one is with respect to like the built-in function. Second type of inbuilt function is user defined aggregate functions. Aggregate functions, UDAF, user defined aggregate function. So over here, like it is going to take input will be multiple rows, and output what it will be, single row only. Output will be single row only. So this is with respect to UDAF. Uh, for an example, say if you are going to calculate say count star. Okay, count star, let me try to give you. So over here, select the count star from this particular table, employee one, from employee one. Okay, so it is going to calculate all the records, the number of records from this particular table. So it is going to take multiple rows as an input and providing me single row as an output. Count star is going to calculate the total number of records in a particular table. So count star, sum, okay, average. Okay, these type of operations are nothing but UDAF, user defined aggregate functions. We are performing certain aggregation over here. We are going to perform certain operations, or like say it might be say some average count. So we are going to take multiple rows as an input over here, and we are going to pass it with the UDAF, and UDAF are going to provide me the output in a single row only. So that is nothing but the user defined aggregate function. Okay, so third one is nothing but UDTF, user defined table generating functions. User defined table generating functions. UDTF. Okay, so once we are talking about these particular functions, let me try to make it more good from the
Uh,
visualization
so
perspective.
in the second
Mhm.
one, in the top you mentioned like analytical function, and in the here you mention it is same or it's different? The second one, if you see
User
in the top,
defined aggregate function.
no, in the top you define na, like the three user defined analytical functions.
Analytical or aggregate, that is the same.
Ah,
Okay,
okay, okay.
okay.
Ashok,
We
one
can.
more thing.
Mhm.
These functions are same for your Hive and MySQL. Huh?
Yes, actually, most of the things we are going to learn over here, that is, we are going to learn in Hive, that is mostly similar to, you can say, MySQL or RDBMS. Okay,
Okay. Okay.
so most of the stuff will be with respect to SQL only. Yeah. Certain stuff will be there, like some commands will be changed over here, say describe command. So over here, say describe table, describe, say employee one. Okay, so it is going to provide you the schema information with respect to this particular table. Okay, but once we are going to use once we are going to run it inside the Hive, then there will be a little bit change. So let me try to show you. Let me mention Hive.
How to come out of this MySQL? Like earlier, you have entered MySQL.
Control C, just press Control C, it will come out.
Okay. Okay.
Okay, so say
Okay.
MySQL hyphen U. Okay, so this is MySQL, and over here what we are having Hive. So show databases and say use bash 32, show tables. Okay, we are having boost analytics and employee table. Say employee table. So previously inside the Hive we were using, say describe uh, table command. So over here, in order to get the details about this particular table, what we are going to use, describe formatted and this particular table. Okay, so it will provide you the information about each and everything of this particular table. Okay, say the column name is employee ID, employer name, salary. Okay, data type is this one. Then detailed information about database is bash 32, owner is Cloudera. This is the creation date, last access time, that is unknown, and the location where this particular table is stored. This particular table is stored inside the Hive warehouse bash 32 db.db, and employee is the table. Okay, so this is available inside the Hive. We know it very well that Hive data is stored inside the HDFS. Let me try to show you HDFS. So user Hive warehouse. So over here, uh, what we are going to have. we are Hadoop, then name node. Inside the name node, we will be having utilities, and from utilities, I'm going to browse the file system. And inside the file system, we are having user. Inside user, we are having these particular things, and Cloudera, history, Hive. So if you are going to create the tables, Hive tables, so those particular tables will be available over here. So inside Hive and Hive warehouse and Bash 32 database, what we have created. Inside Bash 32, what we are having employee table and boost analytics. So let me click the booster analytics table, and what you are able to see over here, this is nothing but the block size and the name is this one. And in this particular table, if I'm going to download, okay, and let me try to open this particular table, what we are able to get, this is the same stuff what we have stored over here inside this MySQL. Let me try to show. Select star from employee. Okay, and this is what we are having inside this table, and same thing we are able to see over here, right? Fine, huh?
Yes, yes, Ashok.
Okay, so what I'm trying to say, you can take this particular data, you can copy this and paste it over here, and we will utilize this particular stuff later on. So we were discussing about user defined the built-in functions, and we have gone through with UDF, that is user defined functions, and it is taking single input as a row as a as an input, and it is providing single row as an output, and these are the examples. Once we're talking about user defined aggregate functions or analytics functions, then it is going to take multiple rows and providing the output in a single row. That is user defined aggregate function, count, sum, average. These are the examples. Now another, like what we are having, third type of built-in function, that is user defined table generating function, UDTF. So with respect to UDTF, what we are having, we are going to say provide single input. Input will be single row. Okay. And output will be multiple row. Multiple rows. Okay. So just have a look. If we are having an array, say, and this is the array what we are having. Let me try to copy this particular array. So this is nothing but one element. Okay, and what I can say, learners. I'm giving a variable booster analytics learners. Okay, so that is nothing but this particular value. So we are going to provide single input, single row as an input. However, like we are having multiple string information, but that is single array because it is passed to this particular single element variable. So if we are going to pass single row and we are going to use UDTF, that is user defined table generating functions, and at that moment we will be having multiple rows as an output. So say the output, we are having one function that is explode. Explode. So if we are going to apply explode onto this, so say explode, and what I can do, explode this particular variable. Okay, explode booster analytics. So if we are going to explode this, so it is going to provide me the outcome like this. We will be having outcome in multiple rows. Okay, so we will be having outcome in multiple rows like this. So explode is a function. It is going to provide me the outcome if I'm going to provide a single row as an input and output will be in the multiple rows. So explode is going to explore the data which is given an array, and it is going to explode all the values and providing you the output into the multiple uh, rows. Okay, that is nothing but user defined table generating functions. Input will be single and output will be the multiple rows. So we will be going to utilize this particular explode function in our today's session with practical. Okay, so practically we will see how we will be able to leverage explode. Okay, so these are three types of functions what we are having used, what we can say built-in functions inside the Hive, and which are utilized in order to perform the specific task. And based upon the input or the data that we are going to process, we are going to leverage these particular functions. However, these are the built-in functions only, but like the the name which is mentioned over here, user defined function, these are the built-in function. We just import these particular functions and perform, we just use type these particular functions and perform our operations. It is not like we are creating the functions by ourselves. Okay, so these are nothing but user defined function, or sorry, built-in functions inside the Hive. Just have a look and ask if you are having any doubt now.
One query, Ashok. If we are
Mhm.
using Hive, then why we are using MySQL?
Huh. Good question. So MySQL is nothing but the RDBMS.
Okay.
RDBMS. MySQL is able to work on small amount of data, and Hive is able to work on to huge amount of data. Okay. Yesterday in yesterday's session, we have seen this particular stuff. Let me try to open this. Okay, so over here, Hive is nothing but the distributed mechanism, or we are having parallel computation over here.
Mhm.
RDBMS, or that is nothing but MySQL. MySQL.
But we will be
Okay,
using Hive only in future, right?
yeah, I'm coming on that particular point. Okay,
Okay. Okay.
so so over here we are going to leverage Hive because we are having huge amount of data, and in order to process huge amount of data, we are in need of a tool which is able to perform, which is able to work on huge amount of data, and I will be having the benefit of parallel computation. So we have opted Hive. That is perfectly fine. Yeah, like I have opted Hive for the computation of my task. But over here, once we are working with Hive is saying, say, it is having two parts. It is having two parts. One is data and second one is metadata. Uh, hmm. So, hmm. We have not written over here. Just a minute. Okay. So Hive is having two part. Let me try to copy it from here. Close this and paste it over here. Okay. So Hive is having two main parts. Hive is having two main parts, or Hive tables, what I can say. Tables are having two main parts. So first one is data and second one is metadata. So data is stored inside the HDFS and metadata is stored inside the metastore. 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 Metastore is nothing but where we are going to keep the data about data, like the information about these particular tables are stored inside the metastore. Now this particular data that is stored inside the HDFS, on which path, on this particular path, so the extension, like the user Hive warehouse, then the database name, DB name, and the table name. It will be table name, and then you will be having partitions. Okay, so inside this, what we were having, we were having this particular file that was having our data. You have seen this over here. So this particular file is nothing but having the data, actual data. So this is the actual data which is stored inside this particular file. So the extension or the complete path what we are having, so it will be user Hive warehouse. Okay, so the data of Hive tables or actual data of Hive tables is stored in this particular path, user Hive warehouse, and then DB database name, and then table name, and then its partitions. It will be available over here. Then the metastore. Metastore of this particular metadata is nothing but RDBMS. RDBMS. So we are maintaining metadata inside RDBMS. Now here is the question, why we need to maintain the metadata inside metastore. We can keep this particular data inside HDFS only. What I have mentioned, let me try to repeat it once again. Hive tables are having two main parts, actual data and metadata. Actual data is the information or the data, like say name and the records which are available. Okay, that is nothing but the actual data. And metadata, like information about this particular table, so that is stored inside the RDBMS. We are going to maintain the metadata inside the RDBMS, and actual data inside the HDFS onto this particular path. Now why we are maintaining metadata inside metastore? So inside, like the Hive or inside the data warehouse, what is happening? It might be possible like we are going to change the schema. Okay, if we are like working in order to modify the schema, or like if we are going to delete a particular table, okay, at that moment what we will be having, the metadata from this particular meta store will be dropped down. Let me try to cover it once again. So manage table and say external table. There are two types of tables inside the Hive: manage table and external table. Now with respect to these particular tables, what we are having, we are having metadata. Now say if we are going to have managed table, and we have fired the drop table command, like we have dropped this particular table, Hive table, then actual data and metadata, both of these particular things are gone. Actual data and metadata, both of these particular things are gone. If we are having say external table and we are running the drop table command, at that moment the data inside the meta store will be gone, but there will not be any impact onto the actual data. Okay, so with the help of this, like if we are having actual data, then we just create a schema on top of this particular data, or we are going to create the metadata, and we will be able to access this particular data. Another thing, once we are having data stored inside the HDFS, that is very important. So if we are going to store metadata inside the HDFS, Then if there are certain change and we need to access this particular data from HDFS, that will be the time taking process. To access something from the from the HDFS, that is having high latency, but to access the data from RDBMS, that is having low latency. So in order to have low latency, in order to access metadata or performing certain change and all, we are going to keep our metadata inside the RDBMS. To have the low latency on metadata, we are keeping our metadata inside the RDBMS. Default metadata, default RDBMS for Hive is Derby. For default default RDBMS for Hadoop is Derby, but that is having certain production challenges. And inside the cloud or a quick start VM, they have uh, clubbed MySQL as a meta store for Hive in order to store our metadata inside the MySQL. So in order to minimize the latency for accessing the metadata, we are maintaining our metadata inside the RDBMS. And because like if we are maintaining this metadata inside the HDFS, then that will be the time taking process, and we want to access the data with metadata basically with low latency. And now the question is, if we are maintaining our metadata inside RDBMS and that is having low latency, why we are not maintaining our actual data as well inside the meta store of RDBMS or inside the RDBMS? Because RDBMS is not meant to deal with the huge amount of data. Okay, it is not able to handle this huge amount of data. That's why we are having Hive, and we have captured this particular data inside the HDFS in the distributed fashion. Okay, but yes, the metadata is very less and we need to have the frequent accessing requirement of metadata. So in order to minimize the latency, we are keeping our metadata inside the RDBMS, that is nothing but MySQL. So because of that particular reason, okay, we were able to see our entries inside this particular MySQL. So this is nothing but MySQL over here, so MySQL, and let me try to use say meta store. Okay, and show tables. So over here we are having different tables, and let me try to say select star from TBLS, that is nothing but a table, and it is maintaining the metadata of our tables. So employee table is nothing but managed table, view expanded. So these are certain details which is maintained automatically by this particular meta store. Now if we are going to perform certain changes, this particular metadata will be changed. Like say over here, if we are performing the partitioning, so partition parameter will be available, and we will be able to see those entries over here: partition key, partition event, a number of partition. Once we will be going through with the optimization techniques, we will be going in detail with these particular tables. Say bucketization bucket table is there, bucketing columns. So we will try to see which one is the bucketing column with respect to a table, and we will apply bucketization on a particular table, and then we will see that particular entry inside the bucketing column. So it is utilized, RDBMS is utilized in order to maintain the metadata of Hive tables. And why we need to maintain the metadata inside RDBMS? Because there might be the requirement of frequent accessing of metadata, and once we need to access the metadata frequently, then then the RDBMS is the solution which is providing me low latency. We will not be able to keep it inside the HDFS because maintaining something inside the HDFS, that will be the non-performant task, right? Clear
So
to everyone?
we create the tables in Hive or HDFS, and that's metadata will get updated automatically, right? So we no need
Yes.
to map
There
anything.
is no
That will
need
be
to
updated.
worry. There is no need to
Yeah,
worry. There is no need to worry.
fine. And
Okay.
we can use
So
Postgres as well instead of MySQL.
yes, you can use any RDBMS. What I have mentioned
Okay,
over here for Hadoop, the default data base or default RDBMS is Derby, but that was having certain production challenges. Okay,
right.
so inside the cloud era, what they have done, they have used MySQL as a meta store for Hive.
Right.
You can use Postgres, you can use MariaDB, you can use RDS. You can you can use any RDBMS to store the metadata of Hive tables. Just you need to change the entries inside the Hive site uh, dot xml. You just need to update
Okay.
those
Hmm.
particular entry over there, and then you will be able to utilize that particular database for maintaining your metadata.
Clear. Thank you.
Fine. Clear to everyone?
So,
So one query, like at what
Mhm.
scenarios we are going for frequent accessing of metadata? Like, is there any use case we can have?
So frequent accessing. So frequent accessing in terms of like modification. If you are going to perform the analytics, if you are going to perform the analytics, you are adding columns, you are creating new columns, you are dropping columns. At that moment, what you are doing, you are modifying the schema, you are modifying the metadata, right?
Okay, sir.
Okay, so at that moment, like there will be change, and with respect to that, it is going to pick up the data from HDFS, and like the operation will be executed in that particular fashion, and you will be able to get the outcome, right? So modification of metadata is like that particular stuff only, because we are performing heavy computations, we are performing the data analytics stuff. And during the data analytics, it is not like we are limited, we are running with the columns which are available inside that particular data. We are going to modify the column structures and all, we are going to change the data types and all. Okay, so that can be the case, and if that is the case, then there will be the need of frequent access of metadata from the metastore. And in order to have the low latency at that front, we are leveraging MySQL or RDBMS as a metastore to maintain our metadata. Okay, so next what we are having is mm, hmm, set functions, set operations. So this is you just need to keep this particular stuff in your mind. User Hive warehouse over here, like you will be user warehouse, user Hive warehouse and DB, then the table name. Okay, and the table name that you are going to create over here inside the Hive. So inside Hive, what we are having this particular table name. So this table name will be reflected as a directory inside the HDFS structure. Just have a look over here. Over here, what we are having inside bash32.db, that is the database what we have created. Inside this, what we are having two directories, employee and booster analytics. So these are two directories. Okay, like prefix d, that is denoting these are the directories. So the file, the table that you are going to create over here inside the Hive, it will be reflected as a directory inside the SDFS file structure. Okay, it will be reflected as a structure, and the data which is maintained inside this particular directory, that will be maintained in term of partitions. You will be having multiple partitions based upon the size of that particular file. So in our upcoming sessions we will be going to visualize this particular these particular partitions are like the file, the table, this particular employee table, which will be reflected as a directory over there, will be having multiple files, and those files are nothing but the partition files, which will be maintained inside the HDFS. Okay, so that is the case. Now you might be worried, like we are leveraging, we are utilizing Hive in order to have a tabular view, in order to have the better visualization what we are having inside the MySQL or RDBMS. So we are leveraging Hive, but over here inside Hive we are not able to see the good visualization. Like the data is in tabular format, but the visualization is not good. So what we are using over here, this is the Hive server 1, and we can utilize Hive server 2 in order to have the better visualization. Let me come out from here. Okay, and what I can use Beeline, that is the server 2 Beeline, and hyphen u and JDBC colon Hive 2 colon and double forward slash. Okay, so this is the Hive server 2 Hive 2, and it will provide you better visualization if you compare it with Hive server 1. So Beeline is started. Beeline is the Hive server 2, and say show databases. Okay, and just have a look, it will be visualized in a tabular structure. Use say batch uh, 32. Okay, batch 32 is used, and say select star from say employee. Okay, now what we are having a little bit better visualization, and it is somehow similar to MySQL what we have seen. Fine, looking good.
Yes.
We are having good visualization in
Yes,
Hive server.
yes,
Okay.
yes, Ashok.
Okay, and employee ID, that is nothing but say employee ID is the employee is the table, dot employee ID is the first column, employee name is the second column, and salary is nothing but the third column what we have created. Okay, perfect. So this is nothing but Hive server 2. Let me copy this particular command and paste inside the chat, inside the notepad. How to access Hive server 2 for better visualization. Okay, perfect. Now the next topic, what it will be, set operations inside the Hive. So once we're talking about set operation, there are three types of set operations inside the Hive. Operations are available in Hive. First one is, it's very simple. With the name itself, you will be able to get the understanding. So union, intersect, and minus. Third one is minus. Okay. So union, intersect, and minus. So once you are going to say we are having certain data. Okay, we are having certain data, and or like we are having certain tables, like Hive table 1 and Hive table 2. Hive table 2. Okay, so we are having two tables, and the two tables are having certain data. Like say inside the table number 1, what we are having say 1, 2, 3, 4, 5. So this is the data of Hive table 1, and what we are having inside the Hive table 2, we are having say 3, 4, 5, 6, 7, and 8. So this is the data with respect to the Hive table 2. So these are certain records which are available. I'm just providing you the understanding what is happening once we are going to leverage union. So union is going to do what it is going to to provide you the cumulative information. It is going to provide the complete data. Okay, so once I'm going to say apply union table 1 and table 2. So what is the outcome that I will be getting? That it will be say 1, it will be the combination of both, and 3, 4, 5, 6, 7, 8. Okay, so table 1 union say table 2. So union table 2, table 1 union table 2. So I will be getting all the records from both of these two tables. That is nothing but the union. Once I'm going to apply union, it is going to provide me the complete records with respect to both of these two tables. That is with respect to the union. Now once I'm going to use say intersect. Intersect, it will provide records from both tables. And intersect, with respect to the intersect, it is going to provide the common records, common records from both tables. Okay, say table 1 intersect table 2. What are the common records? So 3, 4, 5, 3, 4, 5. So these are the common records. So outcome, what it will be, 3, 4, 5. This will be the output. Once I'm going to apply the intersect operation, output, but it will be 3, 4, 5, because these are the common records from both of these two tables. Then minus, once I'm going to leverage a minus operation or minus set operation, so it is going to provide me the outcome from table 1 which is not in table 2. Okay, it is providing me the output from table 1, which is uncommon to table 2. Okay. So over here, what we are having 1, 2, 3, 4, 5, and 3, 4, 5, 6, 7, 8. So inside this particular table, 3, 4, 5 is available inside the table 2. Okay, if we are checking 3, 4, 5 rack codes inside the table 1, so these particular rack codes are available inside the table 2, and which are uncommon records 1 and 2. So output from the minus operations, if we are running table 1 minus table 2, so what it will be? Minus table 2, what it will be? 1 and 2. Okay. Now you need to tell me if I'm going to mention, say, table 2 minus table 1. Table 2 minus table 1. So what will be the output? Table 2 minus table 1. Table 2
Six,
minus
six,
table 1.
6, 7, 8.
What about others? What will be the output? Table 2 minus table 1.
So 6, 7, 8.
Vikas, Rohit, Gaurav,
Yeah, it's same.
Yeah, 6,
6,
7,
7,
8.
8.
6, 7, 8. That is correct. So that will be 6, 7, 8. Perfect. So these are the set operations, and like in order to perform certain tasks or certain processing, we are going to leverage these particular set operations inside the Hive. So set operations are union, intersect, and minus. Then the next topic, what it will be, lateral view. Lateral view. This is very important, and probably you guys are going to utilize in future a lot. Okay. In order to like move with the lateral view, let me try to give you one example. Say I'm having certain data, and in this particular data I'm having some say students, student ID, and student ID say 1, and with respect to the student ID 1, like he is having certain subjects, say English, okay, math, and science. Okay, so these are the subjects with respect to the say student 1, and we are having certain subjects with respect to say student ID 2, and we are having say say history and say English, okay, and say big data. And say third student is having certain subjects, say data science, and data science, and say NLP, natural language processing. So we are having the data in this particular way. We are having students and the subjects. Now, what I just want this particular data, and it I want it to convert in this particular format. Say student ID, and it will be say subject, and I just want to have the data in this particular way. Okay, English, now say math, okay, and science. Why I want to have this? Because like if the data is given in this particular format, okay, then it will be tough to perform the analysis. Like say if I need to calculate how many students are having English subject, so like how I will be able to perform the calculation, or if I'm going to say what is the total number of subjects which student one is having, so although like I will be able to perform by performing the analysis onto this particular array, but I need to write down the complex code for performing that particular task. So the better way what it will be, I'm going to have the data in this particular way, and then with the help of simple SQL queries, like select say student ID 1 where subject equal to English, so I will be able to get student 1 and English, or select star from this particular student table where subject is equal to English, so it is going to list all the students who are having English as a subject. If I want to like use, if I just need to count uh, the total subjects, so I can count with the help of the student idea where student ID equal to 1, and I can apply say count star over there. Okay, so if I'm going to convert this particular data in this particular format, then it will be easy for the analysis perspective. Let me try to mention. It will be easy for analytics perspective. I will be able to perform the analysis easily. So, so that is the stuff, and that is the main need. And if I just want to have the data in this particular format, what I need to do. So what I just, this is the input, and this is my expectation. This is expectation. Okay, this is my expectation. So the expectation is this one. If I'm having certain data, and this is the input what I'm having, and I want to have the outcome in this particular format. So one way, like what I can do, I can explode, use the explode function onto this particular explode, that is UDTF basically. So I can execute explode function onto the subject, and what I will be getting. So once I am going to use explode function, explode function. So what I will be getting, I will be getting the outcome like this. So explode is something say, okay. So once I'm going to explode, so explode, how the explode will work, say select explode, and I can pass this particular subject, okay, explode subject, and from say student table, from student. Okay, so what this particular explode will do, this is going to provide me the outcome in this particular way. Okay, explode is going to perform the output and provide me the output in this particular way, but that is not what I'm expecting. I'm expecting the output, it must be visible in this particular way, like I will be having the student and the subject, like say if student one is having three subjects, so student will be repeated three times, and its subject will be mentioned inside the subject column, so I just want to have the outcome in this particular way. So what I'm going to do, I'm going to have, I'm going to do what? I'm going to say have this particular explode and join it with respect to a particular virtual table. Okay, I'm going to perform the joining of a virtual table that is nothing but like this particular column. Okay, so let it be, let me write it down. Okay, so this is once I'm going to perform apply the explode function, and it is going to explode. Now what will happen, what will happen, I'm going to say select and select say student ID. I'm going to say select student ID, and I'm going to say apply explode. So what exactly is happening over here? I'm going to select, this is the expected output. So I'm going to select this particular student ID and applying explode. Just try to think, okay, try to visualize this. So over here, this is the data. I'm having this particular data, and it is having say student ID and subjects. So what I'm doing, I'm selecting student ID. It is going to select these particular records, say 1, 2, 3, and I'm going to perform explode onto this. So what is happening over here? Say I'm having something like this. So say I'm having, let me try to copy this one, and let me copy say student id 1, 2, 3. So I'm going to select student id, then I'm going to perform explode onto the subject, and once I'm going to perform explode onto subject, then I will be getting this particular outcome. So what is happening, this is a view, okay, which is created, and I'm going to join this particular view, okay, student id 1, 2, 3 with this particular explode, and then I will be getting the required outcome. Just try to visualize this. I'm selecting these particular tables. These are nothing but say virtual tables, which are it will be, it is going to create, it is going to select one row or one column from the student table, and that it is going to to store temporarily, or it will be the virtual table basically, that is utilized for a particular specific task. So this particular view, virtual view, is being mapped with this particular explode output, and then finally I will be able to get the outcome this particular in this particular format. So so that is what is happening. Once I'm going to get the outcome in this particular way, it will be a little bit typical, and in order to, you can say, perform it in a simple way, what I'm going to have, I'm having the lateral view. So lateral view function is going to perform the operation, like say this particular joining and all, it will be happening with the help of this the lateral view, which is the function over here inside the Hive, and I will be able to get the outcome in the required format. So say, just have a look over here. I'm going to say select, say student ID, and I'm going to say select subject, and from where, from say student, and I'm going to have the lateral view, and it will be based upon say subject and what I can do, I can give an alias, say, to this subject table, and I can give the as subject, alias as subject. So in this particular way, whatever I was trying to perform with select and explore, okay, and whatever like we have discussed, say virtual view creation and then joining and all, so that particular stuff is possible with the help of lateral view, which is available over here. And like to convert this particular input into this particular format, what we are having the lateral view, which is a function over here inside the Hive, and just by leveraging this particular function we will be able to convert the required outcome in the required convert the required convert the data, input data, into the required format. So lateral view is going to perform that particular virtual table joining with this particular explored related stuff which is happening in between. So we are going to just leverage lateral view, okay, and it is going to select these particular columns from this particular table, student table, apply lateral view onto explored subject, and we are giving an alias, okay, subject table. After exploring this, we are going to provide an alias, and we are giving a name that is nothing but the subject only, and we will be able to get the outcome. So just like try to proceed it with practical, and before that, like just tell me if you are having any doubt onto this, whatever we have discussed.
In the last query, you go to the last. What will be the output for this?
It will be the same output what we were discussing. This will be the
But
same
but
output.
but we can get the same output from the above query as well. No? Select student ID, explode subject from
This
student.
is like this is something like which will not be, you can say, possible, and that is something like we will be trying to achieve. It will not be executed. You will not be able to get the required outcome.
Mhm. Okay, and one more thing here, we can get the particular from the column out, complete column output. Like if I want to specific, like I want to for the student ID one data only. So is there
Then
any
you can
possibility?
say, then you can add where student ID equal to 1, right?
Okay. Hmm.
Okay.
Okay.
So you
Ashok,
can
it
perform.
will it will create a new table.
No, it is not going to create new table. No?
In that table itself, it will do the changes. Huh?
Yes.
Oh, okay. Then why we have given this alias?
Like you just want to have the subject and student ID and subject. You just want to have, like, if you want to change, say, subject name, so subject name will be available over here, and you
Oh,
just need to
okay.
change subject name over here.
And if I want to change the student ID name as well, then
Student ID.
S- yes.
Okay, select student ID and you can give an alias to, as say, student name or student ID integer. You can give
Okay, at the time of
as,
select itself. Huh?
yes.
Okay.
Okay, so let me try to create a table. Create tables, student, student, students, say, and what I can mention, say, student ID, and that is of, say, integer, and what I can have subjects, and subjects, what I will be having array, array of string. Okay, so I will be having array of string. So that's it. Creation of table, students table. So creation of student table, that is this one. Let me try to, okay, show tables, and we are having student tables. Okay, so describe formatted students. Okay, so we are getting the information, say, a column name, student ID and subject, and array of string integer. So these are nothing but the information with respect to the table. Like we are having serialization, deserialization, input format, output format. If you are not specifying input and output format, so default what it will be text format. Then buckets,
Ashok,
no bucket.
this this information is by default is available inside the
Yes,
database.
yes.
Okay.
Inside this particular batch 32, we have created this particular table, because we have changed batch 32. So database name is batch 32. Cloudera is the user we have created at this moment. It is stored onto this particular location. At this moment, students will be the directory over there. Manage table, okay, storage information, then compressed. This is not a compressed table. Number of buckets stored, short columns, we have not done the shorting. Storage, description parameter null, serialization format. So these are the information about this particular table. Now we are having this particular table, and now what we are going to do, we are going to insert certain records in this particular table. So in order to insert the records in this particular table, what we need to do, we just need to, say, utilize the insert command. So say insert into table, and say table students and values, but it will be say so what I can mention, insert into table students and one, and then say array of what, array of say English, comma math, comma science. This is with respect to say student 1. Then with respect to student 2, but we are having say history and English, that English, history, English, English, and the big data. These are the subjects with respect to student 2, and with respect to say student 3, what we will be having, say data science and NLP. So these are the subjects with respect to student 3, and that's it. So we are going to insert certain records into this particular table. Let me try to insert these particular records. What is the issue?
I think one of the bracket is
Mm-hmm.
In the third row array, then I think we need to close it at then. Yeah.
Mm-hmm. English, array of this one, fine, array of, what is the issue? Let me check the error as well. Unable to create temp file for the insert values expression type token, not spotted insert values. That is fine, I think should work. Bracket, this is started closed. Let me try to, over here like we will be getting some, so closed, closed. looking fine, huh? Or it is taking in single inverted commas. Just a minute. Expecting U of near U of state. Students. Insert expression or TOK function not spotted in insert values.
Ashok, can we just try with single brackets?
Now how you will be able to provide array?
Yeah, this is the issue.
Just a minute. Just a minute. Oh, hmm. Let me try to. It is not accepting in this particular format. So insert into table students. Let me try to mold it a little bit. Select as student ID and array of this as subject. Select star from students. Okay. So like this particular approach is not working in order to insert the values in this particular table. Basically, friends, the main thing is that Hive is not meant to work with this insert operation. Like, however, like we are able to insert or we are able to insert certain records. Okay, in our previous session as well, in today's session as well. But it is not meant to deal with this particular insert operation. This is the time taking process as well, and it is sometimes it is creating or some operations it is not, you can say, accepting. Like if we are going to create the same thing with the SQL, we will be able to create, but over here like we need to change it to a little bit, and then we are able to get the stuff. So we are able to say insert this particular record into the table, and just have a look over here. We are able to see the student and its ID. Okay, student ID is a one, and with respect to this we are having different subjects. Okay, so we are having a record. If we want to insert say more records, let me try to insert more record. Okay, if it is accepting in this particular way, let me try to add one more record, and student insert into the student table, and the table is a ID is 2, and what it will be having, it will be having array and history and all as subjects. So this will be the second record in this particular table. To student ID, let me try to copy and paste it over here. Okay, so if you are having multiple records, then you can insert those particular records over here. It is going to say run map reduce job and all, and then you will be able to have those particular records in your table. Just have a look over here. It is going to execute the map reduce job in order to insert the record in our table. And let me try to run select star from table. So what we are having, we are having these particular records. Okay. So we are having these particular records inside the table. and student ID this, and then we are having this particular record. Okay, so over here, like we are having what? We are having student IDs, and then like we are having the subjects, subjects with respect to the student IDs what we are having. Now I want to show you something. I want to show you something. This is something. This is the manage table. Say describe formatted and say student one. Student. Student. Sorry. Okay. So this is nothing but manage table. Over here, what you are able to see, this is manage table. Now, if I'm going to execute the drop table command, so over here, just first have a look onto this. So let me refresh this, and we will be having student table over here. Okay, we are having student table, and student table is having certain records. Okay, so and this one is something like, and it is having copy of this one, like because we have inserted one record. So student table is available over here, and just have a look inside the MySQL. Okay, so over here we are having the student tables as well. So once we are going to execute the drop table command, drop student one, students. Okay, so if we are going to execute drop table command, and the table will be dropped down. In case of manage tables, once we are going to drop the table, the metadata and actual data, both of these two things will be dropped down. Just have a look over here, and let me refresh it. Okay, this student table will be gone now. Okay, the student table has been gone now. But what about the metadata? Let me try to run. So the metadata is also gone now. Let me try to mention it over here. So once we are running drop table command on say manage tables, then the data plus metadata, both of the 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 things will be gone. Okay, so the data and metadata, both of the things will be gone once we are running drop table command on manage tables. On manage tables. Once, so in order to overcome this particular problem, we will be discussing the external tables as well. So what we are going to do, we are going to say have this particular table. Okay, and what has happened? So student creation of student table was also copied. My mistake. So let me try to paste. The table has been created, and let me try to insert record in this particular table. So one record will be inserted. Okay. So one record will be inserted in this particular table. Then we will be trying to run the lateral view command. Okay, so the map reduce job has been started, and like it has created the table students. Okay, so we are having this particular record. So we will proceed with this particular record, and we will try to to learn how to explore this. So in order to explore, or like in order to apply the lateral view onto this particular table, what we are going to do, we are going to proceed to apply the lateral view functionality. So just have a look. So say this is the table from students, and as subject, so what we are having in this particular table, subjects as an array. So we are going to select subjects as subjects, and lateral view explored, each and everything looking fine. Subjects, select student ID subjects from this particular table. Okay, and explode this. Let me try to copy and paste it over here. From subjects, not as from subjects, subjects as subjects. Column subjects found in more than one table's subqueries. Just a minute. Select student ID, comma subjects from the student table. Lateral view, explore subjects. We are going to explore subjects.
Alias should be different, huh? Instead of
Hmm.
subjects.
Just a minute. Okay, so what we are doing, select student ID. We are going to select this particular subject, student ID and subject, and it will come from once we are going to explore subjects. And okay, so we are taking it over here. Let me try to re-execute it. Okay, so this is what we were expecting, and it has been executed instantly, right? So student ID 111, history, English, and big data. Now we will be able to do a certain analysis. Fine, huh?
Yes, yes, sir.
Clear? Okay.
Yes, clear.
So apply lateral view. And over here what we are doing, inserting records. Records, records, and over here what we are doing, creation of tables. So three things what we have seen with respect to the lateral view. Okay, however, what we will be trying to do in future, we will be having the data in this particular format. Like say we are having certain writers, Salman Rushdie is there, Thomas Otway, Ben Jonson, and we are having certain books like Grimace, Shame, Furry. These are written by the Salman Rushdie and Don Carlos, The Orphan. These are the books which are written by the Thomas Otway. This is the same stuff what we are able to see over here. Like we are having say certain student, and these particular students are having certain books. Now over here what we will be going to see, like say the books with respect to the Salman Rushdie. So Salman Rushdie, and it will be Grimace, Shame, and Furry. Then Thomas Otway, and then Thomas Otway, Don Carlos, and Thomas Otway, The Orphan. In the same fashion like the Ben Jonson, uh, Walpon, and Apicine. So these are the say books which are written by Ben Jonson. Okay, John Milton in the same fashion, like we will be having Comas and uh, Arcadus. So these are the books with respect to John Milton. Okay, so same example, but over here what we are having data in a file, and what we will be going to do, we will be going to insert that particular data in the table that we are going to create. So those particular insert related challenges we will be will not be having those particular insert related challenges. It was not accepting this particular command insert into table and values. So it is not accepting the array once we are like providing the data in this particular format. But yesterday we have seen the insert command was working. At that moment we have not given the data in array, right? It was taking the data once like we are providing the plain data, but once we are mentioning providing the plain data with the plain, you can say insert command, it was throwing error. It was uh, generating talk error. So those are the things like say which are not spotted over here. So what we have done, we have changed the command a little bit, like say we are going to insert into table, and we are selecting say one as a student ID and array of this as subjects. So we are inserting the records one by one. If we need to insert multiple records in one go, then we will be going to use union over here. Union, then second record, then union third record, then union fourth record. In that particular way, we will be able to insert multiple records inside this particular table. Okay, now again the lateral view. So what we just need to do, we just need to say select student and the subject, subject which is coming after exploring these particular subjects. So explode subjects, and it will be like say subject table. It is like providing uh, a parameter, and we will be storing this particular, this is the syntax basically. Okay, this is the name that is given to this particular output, and we are going to mark it as a subject. Okay, mark it as a subject. So we are going to utilize this particular subject over here in order to get the outcome. And we are able to get the outcome in the required format what we were supposing. Okay, this is the format what we were expecting. Okay, just have a look over here. So this is the outcome what we got, and this is the same what we were expecting. This is the same what we were expecting. So we will be able to get the outcome. And over here then what we have seen, like once we are going to run the drop table command, it is going to delete this particular data and metadata which is there inside the meta store. Okay, in order to overcome this particular problem, because we don't want to lose our data, if metadata is dropped, Okay, if something is inside the meta store, like say if you are having, if someone is dropped this particular data, but you are having the actual data available over here, then but by going through with this particular data, you will be able to create the schema. Okay, so just have a look over here. Say this is the employee table, and employee table, sorry, employee directory. This is having this particular data. Let me try to download it and then save and open it. Okay, so we are able to see this particular data. Now on top of this particular data, I can create a table and then I will be able to do the analysis. So if the data is available inside SDFS, by creating the schema on top of that particular data, I will be able to do the analytics. But if this particular data is dropped, then I will not be able to recover this particular data, right? So that is something like which is an issue with the managed table, and this is nothing but the managed table. Say describe formatted and say students, describe, spelling mistake. Okay, so this is nothing but managed table. What we are able to see over here, table type managed table. Okay, and the location where the actual data is stored over here, and metadata information. Do we have metadata information? Okay, meta store information is not available over here. Okay, so this is the manage table, and if you are going to apply the drop table command, so this particular table will be dropped and each and everything will be gone. So that's it for this particular session. In today's session, what we have seen, we have gone through with certain complex data types. Then we have seen certain built-in functions. Then we have covered the set operations, and the last topic what we have seen, the lateral view. Lateral view is going to it is utilized in a lot of cases, like once we are having data that is given with the help of certain you can say you can think in this particular way, uh, inside the Ericsson system we are getting the neighbor information. Say we are having say cell A and its neighbor is a cell B, cell C. Okay, okay, site A, A side B. Yeah. Okay. In this particular format, we were having the neighbor information, right? And our requirement was to convert this particular data into this particular format. Like I want to have all the neighbors of cell A, right? All of you probably you are able to recall. Huh? So lateral view is working over there. Huh? Fine. Huh?
Fine, fine, Ashok, fine.
Yes, yes, Ashok.
So so that is the thing. Huh? So try to do the practice with respect to these things. Like practically we have seen certain stuff, and try to go through with this particular notepad. I will share the recordings as well. Try to go through with recordings, and if you're stuck somewhere, then ping me. That's it. If you are having any query, you can ask. Gaurav.